this week's talk in the Behavior Evolution Culture Speaker Series. We meet every Monday throughout the academic year. That is every Monday when classes are in session at this time in this room. And sometimes there are talks on other days as well, including one this week. More about that in a moment. To find the list of talks, if you just Google UCLA VEC, our website will be at the top of the list, and you can navigate to the page that lists upcoming talks. At every talk, we circulate a sign-in sheet. We ask that you sign that so that we can demonstrate to decision makers that there's a substantial constituency for these talks. Before introducing today's speaker, a preview of coming attractions. This Thursday at 1 o'clock in this room, we'll have a special extra bonus spec talk by Andrew Giersick of the University of Pennsylvania. He'll be speaking on courtship signaling in a social context, what flirting may do for birds and humans.
That's me. So I'll be doing that.
Because of the later time slot, there'll be no lunch. There'll be no lunch at that talk, just light snacks and hot beverages.
Sorry. What time is that talk?
1 o'clock, Thursday, 1 o'clock. And then next Monday in the regular noon time slot, we'll hear from Eli Berman of UCSD with the title Predation, Taxation, Investment, and Violence, Evidence from the Philippines. And then the following Monday, that's October the 28th, our speaker will be Karen Kramer of the University of Utah, and she'll speak on When Mothers Need Others, the Evolution of Parenting, Childhood, and Cooperation. Today, we're pleased to welcome David Nolin of Boise State University, and the title of his talk is What Goes Around Comes Around, Cyclicity as a Statistical Test of Generalized Reciprocity in Social Network Data.
Thank you, Joe. And before we continue, Lisa, I just want to make sure that the mic is registering. Super. I want to thank the department for inviting me to give this talk. As I was tweaking this presentation last night, I had a absolutely horrifying thought. A lot of the statistics that I'm going to be presenting today are social network statistics, specifically a method called exponential random graph modeling, or ERGM. I learned these methods when I was at University of Washington and was taught mainly by Mark Hancock, who's an expert in these methods. The horrible realization was that Mark Hancock is now here at UCLA, and there was the potential he might be here. And he'd be in a position to actually challenge me if I got anything wrong. Fortunately, he's not here for me. But if you have more questions about the methods, you do have a resident expert here at your own university. A talk on reciprocity I thought might be appropriate to start with Solon's. Many of you have probably seen this diagram before. It comes out of Stone Age economics. Solon's model of reciprocity consisted of a series of expanding circles of the social domain, starting within the household, extending out through kinship, through lineages, clans, to the village, into what he called the tribal sector, and not labeled here would be the intertribal sector. And as you expand through this social domain, the degree of reciprocity kind of diminishes in scope and strength. So at the core, you have generalized reciprocity, where individuals are exchanging, readily exchanging food, aid with each other, without regard to the delay between exchanges and without regard to keeping accounts or the amounts that have been exchanged in the past. As you get further and further out, that shifts along a continuum towards balanced reciprocity, in which people do keep kind of mental track of how much they've received from somebody in the past, what they owe to somebody else. They try to keep the duration of delays relatively short or instantaneous in the case of things like barter. And beyond that, you get to something that I've always wondered why it was called reciprocity at all, but Solon's called negative reciprocity. It's reciprocity in the sense that you're nasty to other people just because you expect that they're going to be just as nasty to you. So this is characterized by coercion, theft, deceit, using chicanery to get the upper hand in economic transactions. Now, as here's kind of the schematic of the continuum here. So here with generalized reciprocity, delays are more tolerated, accounts can be imbalanced. With balanced reciprocity, we have more immediate exchange. The accounts tend to be more balanced. In negative reciprocity, if you receive something from somebody else, or more likely take something, you would try to avoid, actually actively try to avoid having to make any kind of return in the future. And of course, that means that you're actually actively seeking an imbalance between yourself and those that you seek negative reciprocity from. I bring this up as a cautionary tale. When I was originally putting together this presentation, those of us that work in the field of human behavioral ecology, I think, have a tendency to equate balanced reciprocity with reciprocal altruism or direct reciprocity, and generalized reciprocity with something that we tend to call indirect reciprocity. If you go back and read Solin's, both of those things would actually fall here in the generalized reciprocity domain. What he meant by balanced reciprocity is something much more neutral, kind of constituting things along the lines of barter exchange or marital affiliations between different kin groups, for example. So here's what Solin's had to say about generalized reciprocity. He defined it as transactions that are putatively altruistic, transactions on the line of assistance given and, if possible and necessary, assistance return, and where the expectation of reciprocity is indefinite. It usually works out that the time and worth of reciprocation are not alone conditional on what was given by the donor, but also upon what he will need and when, and likewise what the recipient can afford and when. So this is the typical characterization of generalized reciprocity. There's less concern about the time delay. There's less concern about whether accounts are balanced. But at this most extreme end, generalized reciprocity tends to be confined to a very narrow group. Within the field of human behavioral ecology, those of us that look at human cooperation from an evolutionary standpoint, we tend to look at a couple of models that might apply here. One is direct reciprocity. This is the model that most people are more familiar with under the name reciprocal altruism, initially provided by Trivers in 1971 and subsequently formalized by Axelrod and Hamilton using models of the iterated prisoner's dilemma. And this is, of course, within anthropology has become a kind of a cottage industry, right? There are now hundreds of papers that look at different ways of tweaking the social situation with these models. Literally hundreds of papers out there using iterated prisoner's dilemma models. When we test for direct reciprocity with empirical data, we tend to test for something called contingency, specifically dyadic contingency. That is, we're looking for evidence that the amount that's given by, say, party A to party B is correlated with what party B gives back to party A. We can contrast that with indirect reciprocity. Indirect reciprocity is a situation in which you give two other members of the group without necessarily expecting the return to come from the same person that you provided aid to. It may come from some other member of the group. So the reciprocity is indirect in that sense. Alexander proposed an initial kind of evolutionary model of that, mathematically formalized by Noack and Sigmund. The models that are used to model indirect reciprocity are sometimes called image scoring models. These are systems in which people keep mental track of who's given to whom in the past, who's in good standing, and essentially works on a reputational system, right? So you know the reputation of somebody else in the group, and you'll make your giving to them contingent on whether they're in good standing and have been providing to other members of the group in the past. So since this type of exchange is not dyadic, we need another way to check for it. And the way that this is typically done is to simply look at there's a correlation between the total amount that an individual gives out and the total amount that they receive back from other individuals in return. So there are two ways that we could look for this in social network data. The network data that I'm going to be working with today has two characteristics. One is that it's binary. So rather than have actual amounts that are being transferred or frequencies of transfers between parties, I simply have binary relationships, whether they reported having a food-sharing relationship, giving to somebody or receiving from somebody. And it's directed in the sense that the presence or absence of the tie between two individuals is going to have a direction component to it. There's a source and there's a destination. So if we have this kind of data, two different ways that we can look for evidence of reciprocity, specifically indirect reciprocity. We can look for a correlation between the total number of giving relationships, what network theorists would say is the outdegree, and the total number of receiving relationships, the indegree. That is the number of relationships pointing in towards an individual or household. But another way that we might think of this, and this to me captures what we tend to think of when we hear the word generalized reciprocity, is this property of cyclicity. So cyclicity is a situation where individual A gives to B, that individual B gives to C, and C receives something in return from A, right? So you're not getting the return directly from the individuals that you've helped in the past. Instead, you're receiving some kind of return from other group members that are all reciprocally exchanging. So schematically, we might think of it this way. The first method of checking this correlation of indegree and outdegree might look like this. So here's our individual or household, perhaps. I've indicated here that they have giving relationships to, say, 4 other individuals. And they have receiving relationships totaling to 4. These may or may not be the same individuals or households that they're receiving from. The important thing here is that there's a correlation with what they're giving out and what they're receiving back in return. So those two ought to be correlated. The second here is the cyclicity. So illustrating here, yellow gives to blue, blue gives to red, and red gives back to yellow. So we can check for evidence of this as well. So let me tell you about the data set and where it was collected. I work in southeast Indonesia in a village called Lamalera. So if any of you are familiar with Homo floresiensis, this is the island of Flores right here. Here's the end of Flores. Lamalera is on the south coast of the island of Lembata in southeast Indonesia, Nusa Tenggara Timur. It's about 1,200 people. People of Lamalera speak a language called Lamaholot that ranges from East Flores through western Lembata, eastern Lembata. They're now Roman Catholic. They have been for over a century, since 1886. That's when the first mission was established. They have a patrilineal kinship system that's directly related to their subsistence system, which is based around fishing and sea hunting. So classically, Lamalera might be kind of classified as a complex foraging society or a sedentary foraging society. Of course, now they're well integrated into the Indonesian national economy. Here's what the village looks like. So you can see it very, very nice, and at least when this picture was taken, very sunny place to work. These are the boat houses actually along the beach. These houses in the background, those are actually domiciles. And another view here. This is a view of the upper village. You can see this is very steep and rocky volcanic terrain. People in Lamalera, for the most part, don't have any gardens to speak of. They'll keep kind of vegetable plots, cooking herb gardens, but they certainly don't produce enough produce, vegetable food to support their household over the course of the year. So largely because there's really, because of the constraints of the terrain, there's not a lot of places where they could farm. Instead, they're engaged in a symbiotic trade economy with these agricultural groups of the interior of the island. The sea hunting season runs from May. There's a mass on May 1st that launches the start of the season every year, and it runs until about August, sometimes into September, largely depending on when whales stop showing up. During that period, they're mainly hunting ray and whales from these large boats called tena. You can see one in the picture to the right there. They're handmade without a single nail. It's all tongue and groove and peg and dowel construction, and they lash everything in and use compression, tension to hold the hull together. There's also some small boat net fishing, little two-man boats that goes on throughout the year. And in recent years, they've shifted more and more towards some sea hunting with motorboats. Now, they won't hunt whales with motorboats, largely because of the hazard of losing the motor. but they will hunt large-bodied manta rays and other cetaceans up to about the size of a pilot whale, but they won't hunt a sperm whale. Those newer motorboats, that they're called Johnson after the most common type of outboard motor that's used. And the two boats have a similar type of organization. There's a corporation of members from typically a single patcher line associated with a single great house. Those individuals all have some responsibility for having either underwritten the cost of constructing the boat in the past, or they have obligations to continue to underwrite its maintenance. So anytime the boat needs an overhaul, they've got to provide the materials, they've got to provide the food and drink to the people that actually do the work. Additionally, there are craftsmen, such as the sailmaker, the harpoon smith, the person that provides the bamboo shafts for the harpoons, the master carpenter, and then, of course, the final group of people that's involved in operating these boats are the crews themselves. So the crews themselves are relatively undifferentiated, except for there is a harpooner that actually has kind of a role of being the captain of the boat while it's at sea. There's a kind of a secondary role played by the helmsman, but the harpooners are typically the leaders of these boats while they're at sea. In terms of what's caught and how it's distributed, we can think of there being two different layers of distribution. At the primary level, all these people that are involved in catching whales or ray with these large-bodied boats, or these large boats, they're all entitled to a share called an UMA. People can have multiple shares, for instance, if they have a corporate share and they're also a crewman on the boat that day. These share rights are very clearly normatively defined, and I'll show you an illustration in just a second about how that works. But we can contrast this primary distribution with the secondary distribution. The secondary distribution involves what people do with their shares once they get back to their house, right? So once they receive their share on the beach, they'll take it back home, they divide it up, and they will share that with other members of the community, kin, neighbors, and potentially other people that are in need nearby. Here's what the primary distribution kind of looks like. It's based on the anatomy of the animal. You can see that there are multiple types that go to, for instance, crewmen, craftsmen, and it looks like in copying this slide from another presentation, some of this text got kind of screwed up. But you can see that there's a number of corporate shares up there that are currently masking the native words for those types of shares. Yes?
That's representational of amount, right? It's not the pieces of the whale you actually get, correct?
Oh no, this is how it's divided up.
Really?
Yeah. But keep in mind, this is not the share that a single crewman would get. So if you have a crew of, say, 8 people, this section of the whale will be butchered off the carcass on the beach and then divided 8 ways. And these shares can be enormous. You can imagine that they range up to 80 to 100 or more kilograms for a single share. The secondary distribution, these transfers of food between households are called vana. In sharp contrast to the primary distribution, where you've got a very clear set of norms that are involved in naming who has rights to what, there are virtually no formalized norms that govern the giving of vana. When I've asked people about, try to elicit any kind of norms that are involved, people tend to instruct me by example. Well, I give to this household because that's my sister, or I give to this household because that's a widow that lives in my neighborhood, right? So you can kind of get a sense of different classes of people that people would give to, but there aren't, for instance, norms that say this part of this animal must be given to your mother-in-law, or prohibiting eating certain types or certain parts of the animal and therefore having to give them to other individuals. You don't have those kind of details. Essentially, It's discretionary and voluntary. One of my key informants had this kind of light go off in his head one day. I was kind of contrasting the secondary distribution with the primary distribution, and the fact that you do have all these very explicitly formalized norms for the primary distribution versus the secondary distribution. And he realized that did seem very strange to him suddenly, that there wasn't a similar system of rules or norms that were going to govern giving of vana. So this is what he said: I don't know why we give vana to this person or that person. There aren't any fixed rules. We just have a feeling in our heart. If I see my neighbor doesn't have any fish, then I want to give him some. And this is relatively common. A lot of people, when they talked about giving and sharing of food, they talked about it in these proximate emotional terms, what they felt and why they felt compelled to do that. This is what the food sharing network looks like. Each of these circles is a household in the village. They're color-coded by administrative neighborhood here. The size of the household is proportionate to how much it's reportedly gives away to others. And the lines represent sharing relationships, ties between households. It's common in network plots like this to put arrowheads onto the ties to indicate how the direction of sharing or direction of relationships. I've removed them. It's already a mess to read, right? You can imagine what this plot looked like when it still had the arrowheads. But the black lines indicate reciprocal relationships, and the gray lines indicate undirected or unreciprocated relationships, so unidirectional. This image probably misrepresents the nature of the data, because what most people tend to see is, first of all, this vast amount of sharing that's going on across the width of the village. And also, if you look at it that way, there seems to be perhaps a lot more gray than black, or at least an equal amount. Well, it really turns out most of the sharing is going on within the neighborhoods, right? So it's kind of covered up. You can't really see it by the nodes here because of the nodes. And most of that sharing at between close households is reciprocated. Yeah, go ahead.
The location of the dots here represents the true location.
Yes, to a point. Within neighborhoods, I shuffled around the location of some of the households just to prevent deductive disclosure. Not that anybody would take their phone, take a shot of this, and then go to Lamalera and say, I know who you share with. But just as a human subject's concern, I did actually somewhat anonymize these data points.
Did you say what the colors mean?
They're just, the colors indicate administrative neighborhoods within the village. So, and my house was right about in here. This dotted area here, we're going to look at again in close up in just a few slides. In analyzing these data, here are some of the previous findings based on work that was performed in 1998 and 99. We know that at the primary level of production, hunting appears to be mutualistic. That is, that they're essentially economies of scale. People hunt these large-bodied animals because they get a higher per capita return rate from hunting large-bodied animals than they would from more solitary or individual endeavors. As I mentioned, the primary distributions are normative, and that's largely what allows people to undertake this mutualistic enterprise. The single greatest predictor of sharing between households, sharing relationships between households, is reciprocity. Reciprocity by itself accounts for about 45% of the variance. When you add in kinship and proximity between households, you get up over 50% of the variance explained, about 52%. Genetic kinship is a better predictor of between household sharing relationships than is social kinship, than is lineage. That's actually the opposite of what's true for predicting who assorts into boat crews with each other. So it's interesting that that's kind of contextual. And then finally, more recently, households of men that are in leadership roles tend to give more than other households, and they receive less than other households, but only after you control for differences in productivity and differences controlling for reciprocity. If you don't control for those things, people in these roles, they both give more and they receive more from others. And that's it's partly a function of the fact that people in leadership roles tend to have more shares and more votes, so they're more productive. But they're also doing the same strategy that most other households do. They engage in reciprocity with other households. So it's only once you control for those things do you see a pattern where men in leadership roles are giving away more and then consequently receiving less than our other households in the village. So this is what I've looked at so far. And as I said, these factors explain about 50% of the variance. So now I'm kind of scraping the bottom of the barrel. I'm interested in trying to explain what I can of this remaining variance in food sharing relationships. This is just showing the proportion of variance explained by these different factors. Distance, kinship, mutuality. Unfortunately, this is a kind of some dissonance between the social network vocabulary versus what we use in anthropology. What we would call reciprocity, network theorists sometimes call mutuality. So this actually, think of this as reciprocity. Again, about 45% of the variance on its own. Distance and kinship, about 15 to 16%. But once you add them in with mutuality, you see that that they don't explain very much more variance than does reciprocity by itself. Right. All right, so for the first test that I talked about, trying to see if there's balance between what's given away and what's received in return. One way we can look at this is to calculate the number of giving relationships a household has and subtract off the number of receiving relationships that it has. So this is the difference in giving less receiving. And if things were more or less balanced within the village, what you'd expect is that the center of this distribution ought to be at 0, which is actually the modal point of this distribution. But you can see there's a very strong right skew to it. And there's also, there seems to be some bimodality here too, right? So we'll see what may be causing this in just a second. If we plot giving relationships against the number of receiving relationships for each household, we get a plot that looks like this. Now, this dotted line here is essentially the slope of 1. If households basically were receiving as much as they were giving receiving in return as much as they were giving away, then we'd expect these households to cluster along this line. What we see instead is that the regression line through here actually has a slope of less than 1. So that means in general, people receive back less than what they give away to others. Now, part of what's going on here, though, is this includes all dyads. So I'm counting giving relationships and receiving relationships, whether or not the other party is involved in the exchange. If we omit from the counts of both giving and receiving those situations where the recipient is the same household as is giving back, if we omit those reciprocal dyads, we get a different picture. It actually looks like this. So if we take away those counts, now we have an actual negative relationship, right? The more you give away, the less you receive from others once you take out what you get from reciprocity, right? What I want to point out here about this slide is that this is not by necessity true that it would look this way, right? It's entirely possible that you could take out all the dyadic reciprocity and still find a positive slope. You could still find that those that gave away more would still be receiving more in return. So this is really interesting that this actually if take away reciprocity, that what you see is that those that give away more are receiving less. This suggests actually redistribution from haves to have-nots.
When you use the label reciprocation, is it based on what they tell you, the reason for why they gave?
Yeah, so the data were collected, a census to the entire village, every single household, 317 households, and asked them over the preceding active whaling season, so a period of 4 months, ask them who they had normally, that is more than once, given food to, and who they had normally, that is more than once, received food from. So that is literally how the data were collected. Yeah. Yes?
Did you ask them that in a general sense and then they free-listed, or did you ask them about each household specifically, like the other 300?
I asked that in a general sense and free-listed. And after names were provided, I always gave the same generic prompt, which was who else. So I just simply asked who else until they said there is nobody else. Yeah. Now we're going to look at cyclicity. So looking for evidence that there are actually these triangular relationships in the data. So here, note that we've got a cycle. I'm also going to look for evidence of something called transitivity. And transitivity looks very similar, except notice in this case, blue is giving both to yellow and to red, and red gives to yellow as well. So we might think of this as blue has some positive social relationship with red, and he sees that red also seems to like yellow. So he may be saying, well, if red seems to think yellow is an okay fellow, then maybe I should be giving to him too, right? So that creates these transitive relationships. This is that neighborhood that I said I was going to zoom in on. I just want to point out, this is what the data look like. I actually went through here trying to find some examples of these cycles and transitive triads that were relatively clear. It's hard to find any that don't also have a lot of reciprocity in them, but here's one situation where we've got a cyclical triad. So this individual is giving to this one gives to this one, and this one's giving back to this one, right? Here's an example of a transitive triad. This node here gives to both this one, and this node is giving back to this one here. So there's a transitive relationship. But there are also quite a few of triads like this, where you can see there's full reciprocity between all three members of the triad, right? So this creates both cycles and transitive triads when you would, if you actually count up the number of cycles or triads in the data. There's a lot of cycles that look like that. This also underscores one of the key things, which is that if we're looking for the effect of cyclicity in these data sets, we want to make sure we account for this propensity towards reciprocity, right? So to do this, I'm going to use something called exponential random graph modeling. As I mentioned, Mark Hancock, who's now here at UCLA, is one of the main innovators of this method. You can perform this in a package called StatNet that's available for R. And if you're curious about this, you can ask me more questions after the talk. And of course, I'm sure Mark Hancock would be pleased to hear from people that were interested in this. For those of you that have had logistic regression, you can think of ERGM as somewhat analogous to logistic regression. It's modeling the presence or absence of a tie in the network by some exponentiated linear combination of variables and coefficients, right? Now you can include in the model, you can include characteristics of the nodes themselves. You can include other social relationships between nodes, such as kinship or distance. And more importantly, what makes this method different from others is that you can include structural properties of the network itself. So that's what we're really going to be doing here, is including both reciprocity and these triadic relationships as means of testing for the presence and absences of ties. The way that it does this is through Markov chain Monte Carlo sampling. It toggles on and off ties within your network, generating a sample of networks like yours. For each of those, it will calculate the network statistics that you've put into the model. That provides a reference distribution from which you can tell whether what the likelihood of observing a propensity, say, towards reciprocity as large as you saw in your data is. The main disadvantage is that it's appropriate for binary network data. But if your network data included, say, sharing frequency or amounts, then you would not be able to use this method. You'd need to use something along the lines of the quadratic assignment procedure or a multi-level modeling approach. One of the problems with triads in exponential random graph models is that they produce what are called degenerate models. Now, if Mark Hancock were here, this is where I would ask him to kind of explain in greater detail what this means. At a practical level, I know that it means that your MC estimation ends up stuck in a small part of the likelihood space. Kind of the search gets lost and it can't escape from that part of the space. In practical terms, it means your model will not converge properly, and you get bad estimation of your coefficients. This is an example of degeneracy. So here we've got a cyclical triple. Each of these iterations is a step in the MCMC sampling, and this is the estimated value of the coefficient. And you can see as the sampling has gone on, this is just launched straight off into la la land. This is not what we like to see. Good mixing looks something more like this, where you're all over the place, but there's a noticeable mean to all the samples, and there doesn't seem to be much of a trend in one direction or the other over time. So triangular relationships tend to produce this degeneracy property. Part of the reason is that this model assumes that each additional cycle that it finds in the network has the same effect, a linear effect on the probability, an additive effect, as every single other one, right? We might imagine that that's not actually a kind of realistic situation. We may instead want to provide some kind of diminishing returns. So we do this by applying geometric weighting to the triads. I have an illustration in a second that'll make this clearer. But essentially, what it does is rather than each additional triad that you could be a part of having the same linear effect on the probability, it means that each additional one has a diminishing effect on the overall probability. So it looks like this. We're trying to estimate the probability of a tie from A to B. And we've got several cyclical relationships between these two nodes. So B gives to 1, back to A, B gives to 2, back to A, and B gives to 3 and back to A. Now, the geometrical weighting has this effect. The weight that's applied to that first relationship may be about this much. But the second relationship applies a diminished amount of effect on the overall probability of that tie from A to B. So that's reflected here with a blue bar. If we added this first and the second one together, this is the effect on the overall predicted probability of that tie. And then again, if we add a third one in, the effect of that third relationship is even less. And if we add that in, the overall effect on the probability would be this. So you can see as you add more and more potential cycles that A and B could be a part of, the additional probability starts to taper off. And then this would have a diminishing and asymptotic relationship here. Right? When we do that, it helps solve this degeneracy problem. It allows the Markov chain Monte Carlo sampling to work more properly. We can get better estimation. It does come at the cost of making this a little less interpretable when you see your statistical results. So here's what the baseline model we're going to look at looks like. This is just reciprocity. So if we put in just a reciprocity term, these are the coefficients. These are in log odds. So if you're familiar with logistic regression, you know that log odds are not mentally interpretable in any sense. If we exponentiate them, that we get a odds ratio. So what this essentially is saying that if you're trying to estimate the probability that A gives to B, and you know that B gives to A, the odds that A gives to B increases by a mass of 185 times. It's a massive, very, very strong effect there. So let's add in the cyclicity term here. So the first term here is the base effect. This alpha is essentially the a factor that accounts for the diminishing probability, right? So this is kind of the main effect of cyclicity and how the weighting on cyclicity is diminished as you add additional possible cycles. Reciprocity remains very strong, and we see no significant statistical effect of cyclicity. I mean, this is, people might want to claim there's a trend here. This is a relatively large data set, 317 nodes, over 100,000 potential ties among those nodes. So I can't really claim that there's low power here, right? It's not if I had a larger sample that I might detect something. I'm not expecting that this is going to improve any. Here's the effect of transitivity, though. Again, strong propensity towards reciprocity. But what this is saying is that rather than there being a propensity to close cyclical triads, there's a propensity to form transitive triads. So for each case where somebody that I give to gives to some third party, that's increasing the probability that I give to that third party. The weighting term itself, not significant, but again, we include it because it helps the estimation of the model. And finally, we can put both of these terms in together. Yeah, go ahead. Shall we go back?
Because a transitive triad is sort of a subset of a fully reciprocal triad, right? It's all but one length, right?
Mm-hmm.
Like, are they separated out in the analysis somehow? Like, does the fact that one is a subset of the other matter, and that transitive is more of a subset than just a cyclical one?
Yeah, so this does bump up a bit against my knowledge of the how exponential random graph modeling works. But my understanding is that when it's coming up with when it's estimating the coefficients for these terms, it's essentially for each network pulled in that Markov chain Monte Carlo sampling, it's actually counting up the number of reciprocal dyads. It's counting up the number of transitive cycles, the number of transitive triads, and the number of cyclical triads. So it's censusing the network, and then using that to create a reference distribution of how likely it is, given your data, to observe, say, the number of reciprocal dyads that you observed in your data, or the number of transitive cycles, triads that you observed in your data, or the number of cyclical triads that you observed in your data. Right? So that's my intuition about how it's actually operating. But again, you have a resident expert at UCLA, so I keep volunteering all of you to contact Mark. I'm sure he's going to love that. Here's the final model with both cyclical terms and the transitive terms in here. When both are included, we do finally see that there is a significant effect on the cyclical triads. But the important thing to note here is that this odds ratio is actually significantly less than 1. So this actually is suggesting that, rather than there being a propensity to form cyclical triads, there's an aversion to forming them, right? Instead, what we're seeing again is the stronger propensity towards forming transitive triads, right? And again, the weighting term, not significant, but still included in the model because it helps us avoid degeneracy and aids estimation.
About the cycles, if there is any reciprocity, does it prevent us from talking about the cycle?
No. So in a triad that had, for instance, some reciprocal ties and also had cyclicity, when that network or where that triad is kind of censused as part of the sampling, it's going to count both the reciprocal tie and it's going to count the cycle. So is that answering your question?
Right, so you could have 3 reciprocal connections, like in an example you showed, and you count as a cycle?
That would count as 3 reciprocal dyads, and it would count as 1 cyclical triad and 1 transitive triad. Yeah. It actually might count as more than 1 transitive triad now that I think about it.
Right.
And would count as 2 cyclical triads, 1 clockwise and 1 counterclockwise. Yeah. The main take-home finding here seems to be that not cyclicity, but transitivity seems to be the triadic effect in these data. What's interesting about transitive relationships is that they are more characteristic of hierarchical relationships. So if you think about the way that employees report to their bosses in a business, you may report both to your boss's boss, and your boss, of course, reports to his boss as well. So that's all those ties are kind of going up the hierarchy. So where we have these kind of hierarchical relationships, we can have 2 possibilities. One is this kind of tribute form where the transfers are flowing up in terms of social power. But of course, the other possibility is that where these flows are going is actually down the social hierarchy. So this is actually forming, it's kind of like charity, going down to those in need. The first of these seems less well supported to me in Lamalera. As I mentioned, previous work looking at the effect of status has shown that those in leadership positions actually give away more and receive less than other households. So if food relationships were going up the hierarchy, we would not expect to see this. We would expect to see them receiving more and giving less, right? What this looks more like to me is that we have a set of households that are in extreme need, and that these are the ones that are being supported by other households in the village. Another section here out of Solin's talking about generalized reciprocity and its relationship to need. There are people who, even in the fullness of time, are incapable of helping themselves or others. A good pragmatic indication of generalized reciprocity is a sustained one-way flow. Failure to reciprocate does not cause the giver of stuff to stop giving. The goods move one way in favor of the have-not for a very long time. So I think what this transitivity effect is really reflecting is this kind of sharing, right? It's not inconsistent with generalized reciprocity as Solins conceives it, but it certainly begs a different explanation from an evolutionary perspective. Here's some data that I've done very little with. These are actual frequencies. So rather than the binary ties that I've talked about so far, I had a subsample of 47 households that I visited once a week and got information on actual frequencies of transfers and amounts. What I've done here is taken, for instance, the households that this household reported giving to, and for that entire sample, the proportion of all transfers that went to the highest ranked house are listed here. So it's, in this case, just about 13% or so went to household number 1, slightly less, 12% to household number 2, and so on. So that's how these rankings are going. The top 2 plots for each of these are giving relationships. The bottom ones are receiving relationships. I think it's best to look at these relationships and think about, for instance, a Gini coefficient, some estimation of inequality among those that are being given to or received from that you could calculate off of these. This is the giving and receiving profile from a kind of a reproductively mature household, a household of which the heads of household are in middle age. They've got some children that are still dependents. And I forget the detail on this particular household, but conceivably their oldest children may even be married at this point. On this side, we've got giving and sharing profiles, giving and receiving profiles for a younger household. This is a household that is just newly married, has 1 child that's still an infant. And what you can see here is that there's really, most of their giving is to one other household. They've got some sporadic giving that they give to others, but when they've given away, they've given 40% to one other household, right? But the number of households that they're kind of dependent on is a much broader suite. So this household that's at the start of its reproductive career is in potentially greater need, is receiving from a greater number of individual other households than it is really giving away to. The mature household shows the opposite situation. They're giving much more evenly to a broader suite of other individuals, and they're receiving from more sharply from a few others, right? So this household, this mature household, is largely giving away more than it's receiving in return. It's reflected in the breadth of other households that it's giving to. The younger household shows a different pattern. So in these transitive relationships, what we may be seeing is that young households like this, and what I'm not showing here, households of, for instance, widows or widowers, are these terminal nodes in these transitive triads. So the next steps, as far as this research goes, involve identifying which households are actually at the terminal ends of these transitive triads, looking at what their characteristics are, especially in terms of household maturity, what their access to the fishery is, whether they hold corporate shares, which can be an indication of need or vulnerability. And similarly, looking at those households that are contributing to these unidirectional flows, that are contributing to these flows that are going downhill, and looking at their characteristics, and seeing especially what these relationships are. Certainly kinship is going to play a role in those that are giving away more to this type of household. And I'll end there. Just want to thank a few people, of course, residents of Lamalera for all of their continued help. My host family, the Bleak-Alone family. John Zeiker and Katie Demps at Boise State University for helpful comments on the presentation. Dedi Adhuri was my Indonesian counterpart on the study, and it was sponsored by the National Institute of Sciences. And funding was provided by NSF. Oh, and this is a fun photo. This man here is a harpooner. This is a cross section through a tail fluke of a sperm whale. It was caught just before I arrived in 2006, and was one of the largest ones that they'd ever caught, 17 meters. And I actually trust that measurement because one of the people in the village had a surveyor's wheel, and they went down to the beach and they paced it off at 17 meters. So that's and that's not even remotely his only share from that whale. It's like one of the smallest pieces that he would get from the whale. But yeah, we'll end there, and I'll be happy to take questions now. Yes.
I might have missed this, but I'm unclear what the unit of, what the currency is here is for these transactions. Is it always just whale meat?
In most cases, it's whale meat. About 75% of transfers are meat of some kind. That can
seems
include
very crucial. I mean, if you and I both have vanilla ice cream cones, it'd be really weird for me to give you mine and you give me yours. If I have a really great cone and you have a lousy cone, then it'd be nice of me to give you my really great cone. I wouldn't really expect you to give back your lousy cone, but maybe you'd come over and do some carpentry for me or something like that.
Right.
So the currency seems really critical.
Yeah. So one of the shortcomings of the study is that it is narrowly focused on food sharing, right? Now, I just want to be clear that the main type of relationship that I was talking about through most of this talk, there are binary relationships. Whether one household usually gave to another or usually received from another. Now that masks a lot of temporal stochasticity, right? People do exchange the same types of food because there's high variance in return from fishing, right? Your boat is successful today, mine comes home empty-handed, you give me some whale meat. Next week, my boat's successful, I give you some whale meat in return, right? So you do see exchange of the same type of commodities. But what's masked in these data is that temporal fluctuation. You do have to graphically see situations where people exchange foods or goods of the exact same type. Ray Hames reports with the Iguana that women that go out digging tubers together will often, or I guess they're helping each other in their gardens, will exchange tubers of basically the same weight and mass. But it's a way of cementing the social relationship, reaffirming that friendship.
many whales are they getting in a season?
So there's wide variation. The mean over about a 30-year period during which a local school teacher kept records was 21 whales per year.
Okay.
Now, in recent years, there's been quite a bit of decline, and the years that we've gone have had much lower return rates than average. So in 1999, I believe, during the time that we were there were 9 whales caught. When I was there in 2006, there had been 3 or 4 whales caught before I arrived, and there were none caught at all during the remaining period that I was there for the study.
And that was the data collected from us, right?
Yeah, so the sharing that I observed was meat that people had already stored and salted on their drying racks. That's the whale meat that was exchanged. Now they were catching pilot whale, orca, manta ray, and doing some small net fishing as well. So those different types of foods were all being exchanged. But it's possible the amount of sharing that I observed during 2006 was actually depressed because there were no whales caught during the active observational period of the study.
It just seems to matter, I guess, if we all get, if there's only a few whales caught and almost everybody gets some through some share in the primary distribution, which is going to be my next question, like what percentage of the village actually gets some chunk from the primary distribution.
Yeah.
Then if there are enough hens, okay, so if that happens, then there's no real need to do this secondary distribution of whale meat if everybody walks away with some, right? If it's
Right.
only 40% of the village gets a share in the primary distribution and there's 6 whale hens, then you could see this, what goes around comes around.
Right. Yeah. So the number of named shares coming from a single whale when 2 boats cooperate to catch it, which is typical, is about 80. So 80 shares. Some of those shares are going to end up at the hands of the same household. So somebody that has a corporate share is also a crewman. Both of those shares go to the same household. The village is about 320 households, 317. So even if every single share went to a separate household, you're talking about 1/4 of the households in the village getting something from a single whale. Now, it is also common when one boat succeeds in catching a whale, other boats will as well, right? So you often do have 2 or 3 whales caught on a single day. I was back in Lamalera this summer, and this is kind of unusual, but they had 5 whales caught on a single day while we were there. So you can imagine when you do have that situation, virtually every household in the village is going to receive something. Yes.
So, you showed that the mature households are more GAV and the immature households more likely to be receive-V, is that right? So, did you notice whether there's any relationship between how generous a mature household might be and how much perhaps the immature households of their children, grandchildren, younger relatives might be receiving? Is there variance in how much a given immature household receives? And
yeah, so that's the next thing I want to start looking at. I looked at that very briefly in my dissertation, but I want to go back and revisit it because I'm at the point where I've explained most of what I can through kinship, distance, and reciprocity, and it really seems that a lot of transfers are based on need. And looking at differences in the kind of maturity of different households seems to be one of the easiest ways of looking at that phenomenon. And I've got 2 ways that I can look at that, of course, with this cross-sectional data where the ties are just binary. But I also do have this longitudinal sample where I actually do have frequencies of transfers and amounts transferred. It's just that those data are just much messier, as you might imagine, and they're still in need of quite a bit of cleaning.
it did seem like in terms of that gentleman's comment about, as soon as you start looking at multiple currencies, then you could find balance where it looks like there's imbalance if you're only looking at one currency. And I was thinking if there's some sort of prestige value to being a big giver, then you could get quickly back to just this issue of food and kind of staying in only a few currencies. If you get prestige for being a giver, that then translates into higher receivership among your extended families because, oh, that's so-and-so's kid, and when I was coming up, so-and-so gave me a bunch of whale tails, so I definitely want to make sure I give some whale tails to that young family.
Yeah, so that's increasingly where kind of empirical ethnographic studies of cooperation are headed,
Yeah.
is to, we've really looked at food sharing in a lot of detail at this point, but we're realizing that we need to expand and look at multiple currencies of aid. So that's potentially one project I'm interested in going back to Lamalera and pursuing. Unfortunately, I don't have that data right now. One indication, however, that multiple currencies are at play comes from looking at households that are actually financially wealthy. Those households actually receive at a greater rate than other households, and they give at a depressed rate than other households after you control for reciprocity. So that means that they have less of a propensity to give without receiving something in return, and they have a greater propensity to receive from others without reciprocating back. Now, it may simply be they're not reciprocating in food, but they're reciprocating with cash or hard goods or other things that they're actually able to buy with money. But that's, I don't have the data. No.
I wonder if you did anything to try and establish the accuracy of the reports you're sort of going on. Did people saying who they gave to? And who they didn't? How do you know that's like an accurate and valid assessment? You said before that they often express these relationships in terms of moralistic terms. Well, it seems like that would prejudice how people would talk about them.
Yeah, so let me address the first part of that. I actually have a paper in the works that looks at this issue of reliability. Because I asked every household both who they gave to and who they received from, that essentially means that every directed tie in the network was censused twice, right? So essentially, A could report or not report that they gave to B. B could also report or not report that they received from A, right? So it's that same directed tie. I'm asking both parties about it. Essentially, they both had that same opportunity to report it.
You only record it if both are accurate.
Well, so that's ultimately what I did. Yeah, I compared the what's called reciprocation of response. Or depending on whether you're looking at whether a reported giving relationship was reciprocated by the potential receiver, or was, I should say reciprocated, confirmed by the receiver, or whether you're asking whether reported receiving was confirmed by givers. You get slightly different rates, but it's about 60% agreement, roughly, which is actually common in network data. There's a body of literature looking at reliability of network data, and that's like right there in the middle of what people typically find. Now, what paper I'm working on shows is essentially that people are much more likely to forget to nominate a relationship that does exist than they are to make one up, right? So given that, so people are essentially, they're forgetful but they're honest, which means you can basically help everybody's memories by including in the sample all those ties that were nominated by either party, and that's what I've done here. Your second question was about the moral aspect of it and whether that had any effect on people's responses. People will explain their motivations for sharing in terms of, especially if they're giving to widows or orphans or things like that. They'll use an Indonesian word kasihan, which means pity or mercy, right? So they do explain things like that, but there's not, all of this behavior is basically public. There's not a lot of sensitivity involved. So you don't have a situation where people are going to be reluctant to talk about it. Everybody just openly talks about it. So I don't think the moral dimension really had much effect on the reliability of the data I was collecting.
If I may, sorry, I'm just interloper here. I'm just wondering whether the holy grail of your mathematical modeling should in fact be accounting for all of the variance. So theoretically, if you were able to build in time delays in the modeling and the different sorts of currencies and people's hierarchical structure, maturity, and all the rest, do you think that it would be best if you could account for all of the variance? What I'm thinking about in particular is the advantage of entropy, the advantage of random variation that can't really be predicted in groups and in systems. I mean, that's a lesson we know from Darwin. random variation can be very good, it can pull you out of local minima that might not be adaptive in the long run. So is it bad that you're only counting for 50% of the variance?
No, actually, as a social scientist, I feel like I've done quite well to account for 50% of the variance. You know, usually, especially if you find a single variable that will account for even 20% of the variance, as a social scientist, you're pumping your fist in the air. So I'm really quite pleased that just 3 variables alone will account for over half. But your point about the variation, especially variation, say, among individuals and their strategies, is well taken. One of the things that I've kind of been arguing, I don't want to say arguing against, but until half a decade or so ago, there was still this trend within behavioral ecology to treat explanations for food sharing as if they were kind of mutually exclusive hypotheses. That it was either going to be reciprocity, or it was going to be kin selection, or tolerated theft. There was these tests that were kind of designed to distinguish between them. I've been trying to kind of move the conversation more, and I think this is where the conversation is largely gone now, to a point where we recognize that it's possible that these mechanisms may be operating simultaneously. So that's why I'm kind of interested in the proportion of variation that different things explain, rather than trying to exclude one or the other. And also this recognition that not just do they explain different amounts of variation in a population. So you may have some households that are giving based on kinship, or some that are based on reciprocity, but that even for a single individual or single household, some of their giving may be based on reciprocity, and some of it may be based on kinship, and so on. So I think in terms of using this type of method to look at variation, we do start to capture some of the variation in strategy that way. Does that address your question?
Sure, thank you.
Joe?
It's a 2-part question. So, is there a term in the language that is roughly equivalent to our term generous, but as like a personality descriptor, not just as an account of what happened at a particular instance? So and so is a generous person. And then the second, if there is such a term, just as kind of a wild guess, or based on your ethnographic intuition, do you suppose that if you ask people to rank the others in the village by how generous they are, you'd get good agreement about that?
Yeah. So there is in the field. I use Indonesian. Local people speak Lamaholot. My Lamaholot vocabulary is very limited. And unfortunately, I can't recall what the Lamaholot word is for generosity right now. But part of my original design involved collecting reputational measures, and I was just for for a number of concerns. I was only going to ask about positive qualities of individuals, right? So rather than ask who's stingy, ask people to rank who's stingy in the village, only ask who's generous, just to keep the goodwill of people. And you don't want to foster an atmosphere where people know that you're asking, kind of gossiping about each other behind their backs, right? Even so, those were probably going to be the most sensitive data I collected, asking people to rank people in the village based on how generous they were. It became clear to me in the field that I wasn't going to be able to guarantee the kind of anonymity of response or privacy of response that the IRB had required of me. And so I had to abandon collecting those data. If I were to go back today, I would find a way to get them that was consistent with the IRB's concerns and still feasible. But yeah, unfortunately, I don't have those reputational measures.
The young households, I'm wondering what type of work those individuals are doing. If they're also working on the boat, doing whale hunting, or if they're concentrating more on net fishing, something like that. So I mean, I imagine if they are working on a boat, participating in whale hunting, they're lower ranked individuals, and so potentially will get lower shares.
Yeah. So so most of these guys from younger households, they are going out on the boats. They're going whaling as ordinary crewmen. They frequently don't have corporate shares in the boats. The corporate shares are allocated among members within the kind of the patrilineage, but those allocations of shares only occur every 5 or more years when the boat needs to be refurbished. Then I gather that there's a process by which people that didn't previously have shares and are members of the lineage can then be assigned a share. But some of these younger households, they only have the share that they can accrue through their own manpower, and that's substantially less food coming into the household than, say, a household that is both crewing on the boat and they have a corporate share, or maybe more than one corporate share, because it's potentially you could have one through the husband's lineage and through the wife's lineage. You could actually have those kind of relationships. I haven't presented on this today, but one of the peculiar things demographically in Lamalera is an incredibly late age of marriage. It increases throughout the 20th century and peaks in the 1980s. Average age of marriage for women was 29 years and for men was 31 years for a subsistence fishing and whaling village. That's insanely late. I have a number of hypotheses about why this might be. But I think one of them may be that there's this obstacle to basically setting up an economically secure household, and it involves the fact that not everybody has access to these additional corporate shares, and that puts these young households that do marry without them in a position of need and dependence on family.
Wouldn't this explain the part of the men, but how about, it's really surprising that the women were as to...
I know. Yeah, it's very strange. And both the age of marriage for men and women goes up in tandem throughout the 20th century. The average difference in age stays about the same at about 2 years. Yeah, that's the really weird part, right? It's one possibility is that there's been bride price inflation, but even in other settings where you have bride price inflation, that tends to delay marriage for men more and more, but not have as much of an effect. It can have slight effect on women. Essentially, men end up marrying older women because they can pay a lower bride price for them, and that inflates the age of marriage for women slightly too. But it's not nearly as exaggerated as you see in Lamalera. You also have tremendous number of children from Lamalera entering the clergy. So since about 1950 or so, Lamalera has produced 19 priests, 2 bishops, and over 60 nuns. There's a tremendous amount of out-migration from the village. Which has created, there's more men than women leaving, and so that's created an imbalanced sex ratio. So you've got a lot of women that are 30 and still unmarried, and they're doing what we would call helping at the nest usually, right? They rather than marrying and reproducing independently, they end up living with a brother's household and helping to raise his children. But if you look at if you look cross-culturally for a similar demographic situation, the closest example is what happens in early modern Europe when the land fills up and you have this shift to unigeniture, where you only have one son inheriting the family's plot and the other children are basically forced to out-migrate. And you see delays of marriage for both women and men in those situations. So it's why a fishing and whaling village's demography would resemble that of early modern agriculturalists is a really fascinating question to me. If there's no more questions, then yes. Yeah.